So this video will be about intermolecular forces. These are forces that hold molecules together to form structure, whatever structure it may be. For example, in a water bottle, such as this, as you can see the water inside of it, it's very stuck together. It's not only just one water molecule inside this water bottle. There are many multiple water molecules in this water bottle. And the way they stay together is through intermolecular forces. Now let's talk about the first one. Let's begin with ionic force. So for example, you know that sodium chloride is salt and it's an ionic compound. It consists of ions, and you know, in your salt shaker you have a bunch of little salt crystals. Those salt crystals are made up of more than one sodium and chloride atom. So the way they stay together is through ionic forces. And that's because in ions, you know that one atom loses an electron, that's why it has a positive charge, and the other atom has a negative charge because it gained one electron. So a there is a formal charge. So that means that in the structure of the salt, the other molecules will be of sodium and chloride will be attracted to the other ones because of the opposite charges. As you can see, the sodium has a positive charge and the chlorine has a negative charge. So they're all being attracted to each other. This is called ionic force. The second force is the dipole-dipole force, and it usually is a force present in molecules that have polar covalent bonds, and it enacts through partial charges. So, for example, in this hydrochloric acid molecule, the hydrogen and the chlorine, they're in a polar covalent bond. And that's because the chlorine is pulling the electrons towards its area. And if the electrons are a little bit closer to the chlorine, then that means there can be a partial negative charge. These symbols here means partial charge. So there's a partial negative charge on chlorine, and that means that there's a partial positive charge on hydrogen because it's losing a little bit of electrons on that area. But it's not fully like two ions, like the sodium and the chloride, because it is a covalent bond. So what happens here when you have a bunch of hydrochloric acid molecules together is that the partial positive charge of the hydrogen will be connected or will be attracted to the partial negative charge on the chlorine. And that's how the molecules are attracted or stuck together. Now, a special kind of dipole-dipole force is called the hydrogen bond. And the hydrogen bond only occurs with hydrogen and these three elements: the fluorine, oxygen, and nitrogen. And being dipole-dipole force, it has to be a polar covalent compound, and the hydrogen will have a partial positive charge and the oxygen will have a partial negative charge. That's how they're attracted together, just like in the water bottle. It is it is demonstrating the hydrogen bonds. And our last force is called the London Dispersion Forces. It's also called Vander Waal forces. And this kind of intermolecular force is present in all molecules. And this kind of force happens when there is an induced dipole moment. So you know that polar covalent bond, it's called dipole dipole because there's poles in all the molecules. Now, what does it mean to have an induced dipole moment? For example, let's have a hydrogen atom with one electron. So we know that there are orbitals in all the atoms, and orbitals are basically known as also electron clouds. They're areas where you can find electrons. So that means that we don't really know where electrons are. Here's the s orbital for the hydrogen. The electron can be found in any place of anywhere in this area. So it could be there, or it can be there, or it could be there, anywhere. Now, when it is called, how do you get an induced dipole moment? Well, of course, hydrogen won't be by itself. Let's have another hydrogen here. So let's say this second hydrogen on the left, it has its electron here. Now, what will happen here? And then this hydrogen has its electron over here. So when this hydrogen meets with this one of them, let's say this one, it will induce a dipole moment on this hydrogen where it will create a pole by moving the electron to have this force, this intermolecular force, to attract these two atoms together. So now, because this electron's on the right side, there will be somewhat of a negative charge on this end of the hydrogen, and then there's a positive charge on the other end. For this hydrogen, there's going to be a positive charge on this end because the electron was moved over there, and the negative charge on that end because that's where the electron is. And now, because opposites attract, these two atoms are experiencing an attraction called the London Dispersion Force or Van der Waal forces. And this applies to all molecules again. So you'll probably be asked which one of these forces are the strongest and which one of these are the weakest. Now here it is. The strongest are going to be ionic forces because ions have a very strong charge on them due to the movement of the electron. Is one of them gains the electron, the other one loses the electron. So of course, having the strongest charge, they'll be attracted, all the molecules will be attracted to one another very strongly. So when you think about dipole and compare it to ionic forces, you can kind of think about two magnets. When you have two magnets, of course, when there's nothing in between the magnets, that's when the force of attraction is the strongest. However, when you put stuff in between, let's say a couple sheets of paper, then it seems like the force of attraction is growing less and less. That's a comparison between ionic forces and dipole forces. Dipole forces, of course, refers to the two magnets with some stuff in between, saying that the electron did not fully go to one side. However, it's still leaning towards one side to create a pole where two molecules can find attraction towards one another. Now the second strongest is hydrogen bonding. Now that one's stronger than dipole. And then the weakest one is London dispersion forces. Now, of course, the strength can correlate to boiling point and melting point. So of course the strongest, it will take a lot more energy to break apart the molecules. So this will have the highest boiling point. So ionic bonds or ionic forces will have the highest boiling point and melting point. And also it shows the same trend from the strongest to the weakest.